Okay, up to this point, what we've done is we have only been dealing with uh, gases that have one component in it, only one type of gas. But now we want to start to deal with mixtures of gases. And so the question is asking us, what's the partial pressure of each gas in a mixture? So that means that we're going to have to kind of invoke some of the rules about mixtures of gases. Well, I've got 40 grams of helium, 56 grams of nitrogen, and I've got 16 grams of oxygen. And that the in total pressure of the mixture is 5 atmospheres. So I'm not going to need to use this particular equation, but let's go ahead and write down Dalton's law of partial pressures. Dalton's law of partial pressures say that the total pressure of an ideal gas system equals the partial pressures of each component. Now, the reason that I write this down is to give some grounding on what the partial pressure is now. I can write that the partial pressure of a component is equal to the mole fraction of that component times the total pressure. Now recall that the mole fraction is a unit of concentration that describes the moles of a component divided by the total number of moles. And so with this information, I can start to attack this problem. So what I need to know is the moles of each component. So I got a little bit of work to do in converting grams to moles. So 40 grams of helium divided by its molar mass. I also need to do the same thing with nitrogen divided by its molar mass. And I need to do the same thing with oxygen divided by its molar mass. When I put those into the calculator, I get 10 moles, 2 moles, and 0.5 moles. Now let's figure out the total number of moles. The total number of moles is going to be 10.0 plus 2.00 plus 0.500. And so I get 12.5 moles. Okay, so I've got some work to do now to figure out these partial pressures. Now let's write those formulas down. The partial pressure equals the mole fraction. So that's the mole of the component divided by the total moles. And the moles of helium were 10 divided by 12.5. That's the mole fraction for helium times the total pressure. Now let's do the same thing for nitrogen. That was 2 moles divided by 12.5 moles, like times 5. And for oxygen, it's 0.5 divided by 12.5 times 5. So let's get our calculator out and work on that. Okay, the mole fraction of helium will end up being 0.8, and 0.8 times 5 is 4 ATM. The mole fraction, so this one was 0.8 times 5.00 ATM. And I get 4 atmospheres. The partial pressure, or the mole fraction of nitrogen, equals 2 divided by 12.5, and I get 0.16. And so 0.16 times 5 is 0.800 ATM. And now let's do the last one. The mole fraction of O2 is going to be 0.04. And so 0.04 times 5 is 0.20 ATM. And let me correct the sig figs here. And so if you add all these together, these should all equal 5, and they do. And so let's correct the sig figs here. So it's 4.00 ATM. And so my answer is 4.0 ATM, 0.80 ATM, and 0.20 ATM. And now we're done.